Hello, everyone. Good evening. Dear authors and invited guests, welcome to the technical session 3A. Myself, Ishita Sauryan, and this session would be moderated by me. On behalf of the Global Knowledge Research Foundation, it is my great pleasure to welcome you all to the 7th World Conference on Smart Trends in System Security and Sustainability, WS4 2023, London, UK. The 7th edition of the conference is being organized in a hybrid mode. The physical event was held in UK, London, 21st August 2023, and the virtual event is being held through Zoom today and tomorrow, that is 23rd and 24th of August 2023. I hope you will enjoy the knowledgeable and interactive sessions throughout the day. In this session, we will have 6 presentations. Each presenter will be given 12 minutes for the presentation and 3 minutes for the question and answers. On 10 minutes, I will raise a gentle reminder. There is another request to all the participants that you all stay connected with us till the closing remarks. If you have any query or update, then you can write it to me in the chat box. Just before we start the session, I would like to introduce you all to the chair of the session, Professor Nilesh Modi. Professor and Director, Dr. Babasaheb Ambedkar Open University, Ahmedabad, India. Dr. Nilesh Modi is having rich experience of around 17 years in academics and IT industry. Presently, he is working as a professor and director, School of Computer Science, Controller for Examination and NAC Coordinator, Dr. Babasaheb Ambedkar University, Ahmedabad. He's holding expertise on cybersecurity and certification on ethical hacking. We welcome you, sir.
Thank you, ma'am.
I would also like to introduce our next session chair, Professor James Stephen Maker, Chair Professor Dr. B.R. Ambedkar Chair, Andhra University, India. Professor James Stephen Maker serves at Andhra University as Dr. B.R. Ambedkar Full-Time Chair Professor. Additionally, he serves as the Dean of Andhra University's Transdisciplinary Research Hub and as the mentor for the American Corner in Visakhapatnam, Andhra Pradesh. He holds more than 21 years of experience in teaching, research, and administration. He's an expert in amalgamated technology with social needs. We welcome you, sir.
Thank you very much, Ishita, for the kind introduction. And I'm so happy to join this session and eager to wait towards your presentations. Go ahead now.
I would like to start with the papers. I'd like to invite Andre to present his paper on the title Conceptualization and Frames of Reference of the Teaching Digital Competence, an Approach from Higher Education. Please go ahead.
Good morning, everyone, and good afternoon there. My name is Gabriela de la Cruz.
Good evening to me.
Good evening to you. Okay, I am here in Ecuador. Now, I am going to talk about the paper, Conceptualization and Frames of Reference of Teaching Digital Competence, an Approach from Higher Education. Can you see the screen? Can you see it?
Yes, ma'am. Go ahead. We could see your screen.
Okay, good. So we, the authors, most of us are from Ecuador. The main author is Andrés Cisneros. Then we have Luis Marquez. Then Gonzalo Samaniego, Mercy Gisbert, Catalina Mejia, Magda Cejas, Benito Mendoza, and me, Gabriela de la Cruz. Most of us work in National University of Chimborazo in Riobamba, Ecuador, and some of my partners work in Spain. So first of all, which was our objective? We want to develop a systematic literature review based on the platforms Web of Science and Scopus about the digital teaching competence in universities. Okay, we focus our research on 3 main research questions. First of all, we wanted to know the main conceptual frameworks of digital competence. Then we wanted to know and identify the most digital competence models applied. And at the end, we wanted to know the importance of the evaluation of teaching digital competence. As an introduction, we found that digital competence is a complex literacy. Literacy that is about skills, knowledge, attitudes, technological, multimedia, and communicational aspects. Okay, so it is a complex system. It was stated by Gisbert Cervera and Steve Mon in 2011. And going ahead, we can see that digital competence is a complex professional competence that joins a set of knowledge, skills, and attitudes that the teacher must possess to mobilize simultaneously and to use digital technologies in their professional practice. Okay, it was stated by Verdupina et al. In 2023. The methodology we applied was based on the Web of Science and Scopus databases. And we did a systematic literature review, and we based it on the publication guide prepared reporting items for systematic reviews, meta-analysis called Prisma about digital competence of university teachers. Based on the variables, conceptualization of the digital competence, teaching digital models, and importance of teaching digital competence evaluation, as I said in the first of the presentation. The results. So we categorize using codes our findings, okay? And we has found that there are a lot of conceptualization. There is a lot of conceptualization about digital competence, okay? So we categorize it by using the Prisma guide, okay? And we have that one category is about media literacy, other is about new literacy, other about multimodality literacy, other about computer literacy, other about digital literacy, that is the biggest one. Then we have media education, information literacy, multi-literacy, digital competence, ICT literacy, e-competence, e-literacy, and digital media literacy. About models, we have found that there are some models proposed, most of them by government. For example, we have P21 model proposed by the United States of America government, okay? Then we have the British teaching framework instrument model, and it is proposed by Education and Training Foundation from the UK Education and Training Foundation, okay? When we have other from the Chile government, okay? We have other from Colombian government, from Spain government, and we have other from United Nations Educational Organization from Spain, okay, Rovira y Virgili University. So those were our main findings about models. About results and conclusions from our research, we can see that the correct determination of teacher's profile lies on the evaluation of the digital competence through validated and reliable instruments. Results of this work depend on the context where the evaluations are carried out and on the variables under study. However, the real importance of the process focuses on the generation of the university orientation plans, personalized, initial, and continuous training, which facilitate the development of digital competence in teachers. It is essential to understand the flexibility of the concept, which has dynamic, multifunctional, multidisciplinary, and transversal characteristics in all areas of knowledge, which allow an adequate personal and professional development. It has been found that most of the instruments used to measure the level of teaching digital competence determine a self-perceived evaluation and focus on instrumental competence. However, the few existing certifications, most of them are private, lack of solid foundation. Integrating digital competence training into the curriculum in a transversal way has a positive impact on the teaching and learning process. Its non-inclusion limits the educational practices. Trainers do not use digital tools mainly for pedagogical purposes, but they use them for technical aims. However, the state of art provides a clear guide on the contribution of teaching digital competence give to development of teaching methods and the construction of pedagogical models with training components that allow creating better digital teaching and learning. The work between the university and the society might be synergistic. For this purpose, it is essential to take advantage of the data obtained from the evaluation of value-adding processes through educational data mining. That's all. Thank you for your attention.
Good. So any queries on this presentation from other people? So what is the future scope of your work? So you did a good work, but what is your future scope?
The future scope for us was to find, first of all, the most important literature about models and conceptualization of teaching digital competence. And then to identify the instruments and models that are applied around the world to evaluate the digital competence, first of all, and mainly in university teachers, because we as Ecuadorians have realized that having a good digital competence is so important for us as teachers, and of course for our students. So we wanted to know how to evaluate our competence and then how to improve our competence to be better teachers.
Yeah, one question from my side. There are different other parameters. You restricted to some of the parameters related to check the competencies of the teachers as well as faculties. So what other parameters we can introduce to extend it for the more scope?
Okay, there are variables and aspects, items that they use to evaluate the digital competence, but the most common are the ones that have to that are related to the skill of the teacher to use the technical and maybe the digital and multimedia aspects. For example, the skill of the teacher to use a platform, an education platform, the skill of the teacher to create new resources, okay? So the parameters that they use the most are based on the teacher's skill.
Okay, thank you.
Thank you.
Thank you, Gabriela. We'd like to move to our next presenter. I'd like to invite author Izzat to present the paper titled OpenAI ChatGPT and the Accelerated Spread of Bias Information. Please go ahead, sir.
Hello, I am trying to share. Can you give me the ability to share? Good morning, good afternoon, everyone. If you're in the European time zones, it's early morning in CDT time. I'm sharing my screen here. Let me know if you can see my screen.
It's visible, sir.
Thank you very much. My name is Izzat Al-Smadi. I'm with Texas A&M San Antonio, and our work here is related to OpenAI, ChatGPT, and misinformation. In particular, in this work, we discussed and we studied bias issues. And I'll talk about those in a minute. And as you know, the rise of ChatGPT and language model in general is bringing a lot of attention these days, and how much those can have impacts in our life and in everything around us, and especially in higher education. There is a lot of discussions in universities now of the impact of ChatGPT and other language models. Bias is one issue, one challenge that we studied in this work. Bias can come from different aspects in machine learning, but as humans also, we exhibit numerous types of biases in our daily life when we make decisions, and ChatGPT and other language models, they are built based on large data sets of text and data from humans and social networks. So kind of they inherit some of the biases that we have as humans. We also discussed that not all kinds of biases are or can be negative. There are sometimes we do some sort of intentional biases to give preferences to certain things and aspects, for example, and this is related to probably discussions of equity and equality. That's another aspect that we studied and mentioned in this paper, that biases, they may look negative in all aspects, but some specific ones they may not. Language models are built based on machine learning models. If you are familiar with language model, basically pre-trained or all forms of language models, but they are typically built based on large data sets of data collected, and this data mostly from open source sources, social networks, Wikipedia, and many others. So a lot of people, they did study bias issues. This is one example I mentioned on bias issues in language models, in particular Suleiman and Kirk. They talked about some of the bias issues in language models, and as we more and more depending on those models as our sources of information, we need to be aware of those possible biases in those models. So the main problem with bias issues in machine learning is that they can negatively impact and affect the integrity of the analysis and the validity of the results. And doing a lot of evaluation in machine learning papers, problems probably you as well notice that a lot of reported results in machine learning they lack the talk about the bias, because some models having high accuracy in certain data sets, they just have that high accuracy and performance because of bias in the models, but authors intentionally or unintentionally decided to ignore that in their discussions. So sometimes results are too good to be true. They are very, very high just simply because the focus in the model or the data we're not sampling and representing, you know, all data set, all domain, and those kind of biases that happen in the typically in machine learning. So we talked about all kind of biases, and we did the kind of systematic literature review in the different types of biases. And in this slide, I'm not going to go through those. I listed examples of 15 types of biases: learning bias, inductive bias, hyperparameters bias, and those biases mostly related to machine learning. Co-occurrence bias, framing bias, uncertainty, brilliance, social bias, stereotyping or stereotypical bias, and bias. Some papers, they talk about bias, the bias in bias itself, direct versus indirect bias. This is just the beginning. Like I said, the bias is really a very sensitive and serious subject, and this paper is introductory for more investigations on those different types of biases and how much impact they may have on language models in particular. Again, going back to, is all types of biases harmful? When large language models such as GPTs are heavily used in making decisions and maybe receiving informations, concerns about credibility and accuracy of those language models. But when we talk about all kind of biases, not all kind of biases are harmful. Like I said, typical example when we talk about biases, for example, in our higher education, when we give preferences to minorities, for example, that's a bias, but that's not seen as a negative kind of bias, because again, it's related to equity and inequality, and give opportunities for those that they may not typically have the same opportunities. And so we do inject biases in our human life, and again, that can be simply and easily inherited in those language models. If large language models collect data from the internet and they used data from public sources, those can be also biased. Take an example, history, for example. If you read about the same incident from different pieces of papers, you may see different views about the same historical event, supposedly talking about facts, but really humans always present their perspectives and views that can be different, and that's another kind of bias that we experience in human life, and those models, if they are collecting data from us, then they will inherit those kind of biases as well. Naturally, their first choice is a disease that comes. I'm giving an example here again for humans and making decisions. For example, a medical doctor who's trying to diagnose a patient, and in mind they have different possible diseases. Sometimes the first choice can be context driven, based on maybe the gender, based on the age, based on the country. This kind of disease is typical in this area, and so the diagnosis by the doctors, maybe for the same symptoms, can be different from one patient to another. bias is much broader than machine learning. Again, we as humans, we do experience bias in different aspects. And again, not all those biases are harmful or negative. But if we have such extremes where some biases have harmful impacts, while others are desirable and have possible impacts, the big question will be here is how we distinguish, if and who can distinguish that this is an okay bias, but this is not an okay bias. And again, language models, if they are going to inherit all this from us, how readers of those decisions or information from language models can also distinguish that this information has a possible bias, and it's not an absolute fact. It's representing the context of the person who's the language model maybe build that information based upon. One can argue while that automation programs and machine learning can limit or reduce some of the biases. So we think that machines are not like us. Machines are basically hardware. They don't have bias. But when we talk about ChatGPT and language models, knowing and understanding that those language models, they made their decisions based on that training data set that they have, so they could inherit the same kind of biases that we have in our human life. There's no doubt, in conclusion, there is no doubt that ChatGPT, in particular 3, the most recent one, holds incredible promises for future. As one of the authors that we cited points out, various forms of AI can now outperform expert humans, not only in fairly mundane ways in games, etc., but also in domains such as medical fields, for example, where people are talking about language models as possibly replacing expertise of medical doctors. What about the downside, the negatives, the issues such as the bias? As university professors, for example, in our case, and this study, we focus about the kind of impacts in higher education. We routinely deal with complex issues of plagiarism, for example. This is an ongoing challenge in all universities these days. The problem is that authentication tools such as Turnitin and iAuthenticate, etc., they may not catch text that's coming from language models such as ChatGPT, and this is really a big challenge for higher education. If you ask your students to write an article, etc., and they went and used ChatGPT, and how you can evaluate that this is genuine or not, that's one of the challenges that currently we are pursuing this research in. Thank you very much.
Yeah, that's a nice presentation.
Thank you, sir.
Yeah, but now.
Yeah. My question is actually, you talked all about the negative sides of ChatGPT and AI. So you didn't talk anything about the positive sides of AI and ChatGPT.
Yeah, that's a good point. But that our focus was on the challenges in this paper. But of course, there are many good things, and in fact, universities at the same time, they are using. Our university in particular, they are using ChatGPT and language models as document writers, to write like things like manuals, and that they will be very time consuming to be done by humans. So there are many good things, to utilize language models for sure.
Yeah. Yeah, the point is you used ChatGPT 3, but the 4 is available, right?
It is, yes. By this time, it's so, and there are many language models. A lot of people, they think, and that's why I like to use. Now they use a lot of universities. They use AI. I think they call them AI generative models, as, because ChatGPT 3 or 4 is just one instance from one organization, and there are many others out there.
Yeah, I saw categorically you mentioned ChatGPT 3. So now we are using 4.
Right.
Yeah, good. So thank you. I think we can proceed to the next presenter, please, because we have the time constraint. My request,
Yes.
directly get into your content, skipping the introductory part more, and so that we can listen to your contributions more. Thank you. Yeah.
Please stop my sharing. Thank you.
Okay, so we'll be moving on with the next presenter. Thank you, Sir Izzat. I'd like to invite the next presenter, author Ihor, to present the paper titled System Information Model of Digital Twins. Please go ahead.
Yeah, let me start. Okay, dear chairman, dear participants, for your attention is invited to our topic, System Information Models of Digital Twins. This work was carried out by employees of Department of Computer Intelligent Technologies and Systems, Kharkiv National University of Radio Electronics, and Faculty of Information Technologies, University of Jyväskylä, Finland. The content and structure of work presented on the slide. The paper considers systematic approach of modeling unified system information space, USIS, and product lifecycle system information, PLSI, of virtual digital production. An analysis of system information models of process and systems was carried out, and the definition of a term system information was proposed as a proportional ratio of a general attribute to its particular value. A methodology for system information modeling of this information space is proposed, and analysis of system information models based on the Planck units of physical quantities is carried out. Examples of production tasks using system information models are given. The developed principles of system information modeling are based on specific provisions in the field of information theory. Formalization of system information models of processes and systems is based on the postulate and 3 rules for establishing communication dependencies of interacting objects represented on the current slide. Postulate: the change in the state of the object is as a result of external information impact occurs discretarily, starting from threshold of the object's sensitivity to this impact. Rules: first one, the rule of communication reflection. Second, the rule of communication agreement. And last one, third one, the rule of preservation of communicative abilities for closed systems. And the system information of an object is characterized by an informational measure and the informational norm, shown in the current slide. The information measure is a function of absolute value of a quantitative and or quantitative proportion of ratio of the attribute to established measure. The informational norm is equal to the value of ratio of general value of attribute to its particular value. Based on information measure, the amount of information on the first kind is determined. Based on the information norm, the amount of information and of the second kind is determined and presented in this slide. The set of information values of the first and second kind is general system information of processes and system with a single sensitivity threshold. The methodology of system information modeling is based on the concept of system information, which is characterized by a quantitative indicator of the communication ability of an object to exchange information with the environment. In the process of system information exchange, the object changes its state by a value that is a multiple of the thresholds of sensitivity to the influencing object. Characteristics of system information models are shown and presented on the current slide. Here slide shows the structure of system information space, which reflects various fragments of reality of the manifestation of the systems. These can be fragments of reality that reflect the property for the object, space, and time. The structure of system information space consists of three main blocks. The central block is a fragment of reality of the set of object properties, the so-called intensity of properties. The other two blocks are duration time block and length block. These blocks are characterized by limiting boundaries of duration and extent and threshold of sensitivity of duration and extent. The combination of elements of block of intensity, duration, and length in various configurations from layers or fragments of reality. Product lifecycle process management is implemented on the basis of the USIS digital twin, which is built on the system information models of processes and systems. This slide shows the structure of software product of USIS in the digital twin. It's built on 5 coordinates that reflect, firstly, system information about properties of the object. Second, system information of 3 coordinates of manifestation of properties of the object. And last one, system information time, duration means, of the manifestation of system information of the properties of the object. As a platform for managing both virtual and physical production processes, the product life system information software product is used, which is system compatible with the PLM, product life cycle management, technological system software. The slide presents the types of system information models for parameters PLSI software, product object. PLSI object models are divided on 3 types. First type, system information models of priori information of parameters. Second, system information models of posteriori information of parameters, and last one, system information models of parameters of information processes. System information models based on 2 kinds of system information expand the information space of the digital twin when solving production tasks and increase its efficiency. The system USIS plus PLSI of the digital twin uses system information models of virtual and material production of 4 types: absolutely, relative, equivalent, and mixed. And it's all these types presented on the slide. Here we can see digital twin management tasks based on USIS plus PLSI and PLM system. This includes follow tasks, 6 tasks. First, management without loss of information, regulation, adaptation, stabilization, self-organization, and self-learning. And other tasks, not so important. Using a system information approach of model, digital twins of production allow to effective problem solving related to analysis, synthesis, management, forecasting of production based on the quantity, quality, and value of system information that characterizes the parameters of production processes and systems. In general, the following conclusions can be drawn from the work. First, system information models of the digital twin reflect the system information of the parameters of processes and systems, real production. USIS of the digital twin is used as a PLSI platform for managing both virtual and physical manufacturing processes, which is system compatible with PLM technology software. And combination from USIS, PLSI, and PLM system of the digital twin is a database and algorithms of material production processes as the stages of the product life cycle, and significantly expands the list of production tasks to be solved and their efficiency by increasing information content of virtual and material parameters. And last one, the basis of combination USIS, PLM, and PLSI system of the digital twin, the task of production management, design a new product, technological preparation of production, and task of economical planning, forecasting, and other tasks will solve it. And as conclusion, I already pronounced it. Thank you for your attention. Questions, please.
We'll proceed with the questions.
Yeah, any questions from the floor? From the participants?
Since there are no questions, I guess we'll be moving on with the next presentation.
Okay.
I'd like to invite author Dominic to present the paper titled The Business-Oriented Extension of the Sustainability Awareness Framework, a Design Science Study. Please go ahead.
I hope everyone can hear me.
Yes, you're audible.
Super. So thank you for coming to our presentation. I wrote this article together with my PhD supervisors, Stefanie Beetz and Jari Porras, located in Furtwangen, which is in Germany, and Lund University, which is in Finland as well. So I would like to start with this phrase. Software systems have become deeply intertwined with both our personal and professional lives, blurring the demarcation between the colloquially referred real world and the digital world. So consequently, software systems wield unintended influences on non-technical systems encompassing the social, environmental, and economic dimensions, so sustainability. Those three dimensions are commonly encapsulated under the triple bottom line term, which serves as a conceptualization of the term sustainability. You can see the triple bottom line model from John Elkington at the left. And these three pillars encompass the fundamental aspects that companies need to consider when evaluating and enhancing their sustainability practices. Here on the right side, you can see another model in the light of increasing concerns about environmental and societal challenges. The triple bottom line assumes prominent importance on one side, in the perspective of many sustainability advocates, but on the other side, also critics. On the right, we can see an example of a systemic visualization of the topic sustainability that puts the ecology at the top, then society, and then comes the economy. In 2015, the SDGs were introduced in part of the 2030 agenda of the United Nations. And those SDGs aim to address global challenges such as poverty, climate change, inequality, and so on for a sustainable future. Other developments in recent years, which cannot be discussed in detail here for reasons of time, illustrate that the concept of sustainability is currently gaining in importance. Those developments, of course, have an influence on companies, at least the ones in Europe at this list here. But this development is more or less visible all over the world. However, delving into sustainability also entails an additional workload that comes with associated costs. Software companies face a dual task in bringing together the requirements of sustainability design on one side and sustainability and business plan design on the other side. To give you an example, depending on the product or service, it could be argued that privacy suffers because of the display of personalized advertising. But on the other hand, this solution enables the company to pursue a pricing policy that allows economically worse off user groups to use the software, for example, students. And I don't want to take this scenario any further at this point. This example highlights only the difficult complexity of designing and developing software products and services that you can call sustainable. You always receive trade-offs. It is not an easy task to be sustainable. So the main RQ of this paper and my dissertation is how can companies effectively integrate software sustainability design requirements into the business plan. And now we come to the method. It's design science research, a problem-solving paradigm that aims to enhance human knowledge by creating innovative artifacts. The goal of design science research is to understand and improve design processes by creating an artifact to solve a problem with an underlying analysis of its performance. Havner, a researcher, adds that the artifact must relate to a herefore unsolved and important business problem. Our approach is founded upon Peffers et al., which has emerged as the most frequently cited model. It involves 6 steps. First, identify the problem and the motivation to solve it. Define objectives of a solution second, then design and development, then demonstration, evaluation, and communication. We see 2 main problems we would like to mention here. So first, that's what our interview studies and survey studies showed, that there's a lack of understanding regarding sustainability among software practitioners, including implementation and goal setting. And within an industrial context, software can be conceptualized as the outcome of a unique collaboration involving employees and maybe other stakeholders. So consequently, these collaborative efforts have implications for sustainability outcomes, and there is still a lot of work to be done. And the second problem results from our observation with this frequently used tool here, the Sustainability Awareness Framework, or short SUSAF. It was created by an international group of scientists to support software practitioners to identify, comprehend, analyze, and subsequently discuss the potential impacts that software systems may have on 5 dimensions: social, individual, technical, economic, and environmental. You can find the SUSAF workbook on our website, suso.academy. SUSO stands for Sustainable Software. And here you can click on Tools in the menu and then click on SUSAF. Then you have the workbook. The only thing you need to know now is that this tool helps to uncover potential risks. Airbnb, for example, can lead to gentrification, according to a study conducted in New York using this tool. So the process in companies looks like this. The software engineer or maybe requirements engineer familiarizes himself into the topic, uses the tool in the company, and shares the information for consideration at the end. And the problem is that we are dealing with a highly complex field that is not easy to get to grips with. And then how should it be taken into account in the business plan? What to do with all those information? We conducted 6 workshops or case studies with software companies in total, and those were the topics. I think each topic tells you something, but maybe not this one. It is a subject that affects everyone and therefore only seems invisible, but it is in our eyes quite important. And here at this study, at WS4, we presented the artifact with automated manuscript analysis for publishing houses. And now we come to the result. The artifact consists of 3 overarching phases: preparation, workshop, and follow-up. It is not the software engineer who should plan and conduct a workshop, but someone in an interface position from management, for example. For example, the project manager or the product owner would be suitable. Stakeholders should also be integrated, also external stakeholders, a heterogeneous ensemble of diverse ones. Sufficient representability should be ensured in order to generate comprehensive results. Then later we come to the workshop, which starts with a presentation into the topic, and then comes the value proposition canvas, because we identified the user as the most affected by the software. He is directly addressed. On the right side, we can see gains, pains, and customer jobs. And on the left side, gain creators, pain relievers, and requirements for the software. So what is the software about and who uses it, how? That should be clear at first. Then comes the SUSAF. So it is embedded into something bigger. And it is not about the content here. For that, I recommend to read the paper. It is more about the components of the artifact itself. So, and then we come to the traffic light business model canvas. The actual business model canvas, or BMC, has been modified so that stakeholders divide into 3 levels here. Green means sustainable, yellow is appropriate, and red is unsustainable. And at this point, it should be noted that the distribution to the sustainability levels here is assigned by the stakeholders themselves during the discussion. So the extent tool is reminiscent on traffic lights and road traffic, hence the name Traffic Light Business Model Canvas. And lastly, the follow-up. After analyzing the results of the workshop, it became evident that certain conditions needed to be met for the development of the software to be feasible and to minimize the risks associated with it. Firstly, it required the participation of industry partners. That was a result for this software. And secondly, a successful application for an appropriate funding program. So maybe funding is needed or should at least be considered. And then lastly, the SUSAF and the TLBMC is useful for implementing the sustainability priorities of the stakeholders into the business plan. So we recommend to not only use the SUSAF as a workshop, but to embed it into all this here. Now I come to the conclusion. The BE SUSAF encompasses 4 key extensions that make it suitable for industrial application. To encapsulate these fundamental principles, they were named the 4 I's because of the I's here. At the left, interface position for the orchestration of the artifact, integration of external stakeholders in the requirements electation process, implementation of the SUSAF results within business model designs, incorporation of organizational conditions within software companies. So overall, this work supports the achievement of sustainability goals in 2 ways. First, the artifact facilitates the industry in its pursuit of introducing sustainable software products and services to market by combining software sustainability design and business plan design in a theoretically grounded and practically tested way. And second, the research around the artifact empowers academia in including the realities within the corporate landscape in the development of further approaches to sustainability design. So all in all, in this regard, this work is also to be understood as an invitation to both industry and academia to participate in building bridges to each other by entering collaborations. The further the digital transformation progresses, the more significant the topic of software sustainability will be. And in response to emerging challenges, collective effort forms the basis for solutions. And this, the BE SUSAF could be one of the solutions. So thank you for your attention and your time.
Thank you, presenter. We'll go along with the questions. Any questions, anyone?
I don't have any question.
Please go ahead, sir.
Yeah, that's a good presentation, especially about the Sustainable Development Goals of United Nations. And What are the evaluation methods you consider to evaluate how far the sustainable development goals are achieved? Any specific evaluation criteria is taken?
Yes, we evaluated all the workshops, and we evaluated the content, the structure, and also what needs to be done in the future. So, like, are there any other stakeholders that could help the companies to embed sustainability considerations into their efforts? And yes, so yeah, we made a survey after each workshop or case study, and the results were all in all quite positive. The negative thing is the time factor, or we could call it negative, it depends, because you can't go a lot into the deep here, because it's such a big topic. So we recommend this artifact as an initial tool, and afterwards you still have to go into the deep and to continue to work with the topic sustainability. But it's good to not start with like only ecology, so which energy do we use, but to see the bird's eye perspective, and yeah, and that was one of the results of the survey, so one of the most important ones.
Have you considered all the 17 SDGs, or did you take only part of it?
No, the SUSAF was created also with the SDGs in mind, and also the questions, their interrelations, their connections between the SUSAF questions in the templates and the SDGs. But yeah, we can also say that there are differences, like the topic of software. I think it was not so much considered when building the SDGs. So there are differences. Yeah.
Got it. Thank you. Good job.
Yeah, thank you too.
Thank you, Sir Dominic. We'll be moving ahead with this next presentation. I'd like to invite Sir G.V. Janderi to present a paper titled The Double Hump Effect in the Conductive Polar Terrestrial Ionosphere. Please go ahead, sir.
Yes, I am here. Now I am sharing screen and prepared my file for presentation. Is it okay?
Yes, sir, it is visible.
May I start?
Yes, sir, please go ahead.
Thank you very much. This is title of my report. My report is devoted to the radio waves propagation and scattering in the conductive collision ionospheric magnetized plasma, abbreviation Kokoima plasma, with electron density fluctuations in both polar and equatorial regions of the terrestrial ionosphere. This is outline of my presentation. Investigation of the statistical characteristics of scattered electromagnetic waves in different random media is one of the important problems in many practical applications associated with both natural and laboratory plasmas. In analytical and numerical calculation, we use different spectral functions of electron density fluctuations containing ionospheric conductivities such as Hall, Pedersen, and longitudinal conductivities, taking into account anisotropy parameters characterizing the given problem. For example, the direction of an external magnetic field, the velocity of a plasma flow, and electron density irregularities. Electron density irregularities usually have a spheroidal form due to diffusion processes along the geomagnetic lines of forces and in perpendicular directions. We took into account also the anisotropy of electrodensity irregularities, such as the anisotropy factor and angle of inclination of elongated plasmonic structures with respect to the geomagnetic lines of forces. We took into account the diffraction effect. This is very important as far as we discovered a new effect as a double hump. I have named this effect as double hump effect caused due to diffraction effect. If the waves propagate long distance in the turbulent plasma in the ionosphere, the double hump effect arises. If no diffraction effect, the double hump effect disappears. The main theoretical tool describing short radio waves propagation and scattering in the Kokoima plasma is the ray theory. It is based on the solution of the set of differential equations characterizing the ray trajectories. This slide illustrates absorption altitude dependence of scattered ordinary and extraordinary waves in the Kokoima plasma. Here are presented ray trajectories using the complex geometrical optics approximation and Wenzel-Kramer-Brillouin method, characterizing the complex geometrical optics approximation. So this maximum characterizes curves of the reflection point. At first, the rays corresponding to all frequencies follow the same trajectories. Getting into the plasma slab, their paths are separated. High frequency waves penetrate high altitudes. Low frequency waves return to the ground, reflect off the ground, and return to the ionosphere again. This is a novelty of this problem as far as nobody considered conductivity of the ionosphere for in the investigation of the statistical characteristics of scattered radio waves of different frequencies. This slide illustrates the anisotropy of electron density irregularities. They are characterized by anisotropy factor, the ratio of longitudinal and transversal spatial scale, and orientation angle. The initial is the wave equation for the electric field, containing the dielectric permittivity tensor, which contains the constant mean and fluctuating term, which is a random function of the spatial coordinates. Permittivity tensor contains the magnetoionic parameters and ionospheric conductivity, such as Hall, Pedersen, and longitudinal conductivities. Randomness of the electric field is in the phase. Here we present only three terms. First term is a regular term. The second term describes the waves propagation along the z-axis. The first term contains the transversal wave number and characterizing disorder of an incident radiation. The second and third term are random function of the spatial coordinate and characterizing fluctuation of the phase. This is the important parameter. This is a diffraction parameter characterizing disorder of an incident radiation. We discovered the new effect, the double hump effect, which is based on this parameter. If this parameter is 0, the double hump effect is disappeared. This slide illustrates the ray trajectories in the propagation plane or against the background of electron concentration distribution. The spacecraft is located on an altitude 400 kilometers above the Earth's surface. The receiver is located on the Earth's surface at the origin, and from the figure it follows that all rays radiating by the spacecraft flying in the ionosphere, all rays trajectories coming to the observation point. The right figure illustrates the difference between the refractive indexes of the ordinary and extraordinary waves in the ionosphere. We first time calculate analytically both the refractive index of both ordinary and extraordinary waves, taking into account conductivity of the ionosphere. Nobody considered this problem till now. The shape of this curve is correlate with the electron density, electron concentration profiles along the ray trajectories. Absorption caused by collision between plasma particles substantially depends on the spatial power spectrum of electron density fluctuation. It is very important statistical characteristic which is equivalent to the ray intensity or brightness, which is usually entered to the radiation transport equation. This slide illustrates the dependence of the variance of the phase fluctuation versus the root mean square of electron density fluctuations. We used different spectral functions, for example, a power law spectral function, anisotropic Gaussian correlation function, hybrid of these spectral functions, Kolmogorov spectrum, and other one. This slide illustrates the rate trajectories for the power law spectral functions containing experimentally observing space spectral index P depending on the perturbation level of the ionosphere and an altitude. In a calm case, the phase spectral index varies in the interval 1.7 up to 2, and this curve is significantly less than other one corresponding to highly perturbed ionosphere. So for the perturbed ionosphere, experimentally observing space spectral index P varies in the interval from 3 up to 5 and even to 6. So value of the mean square deviation of the phase fluctuation increases in proportion to small scale electron density irregularities, causing both phase and amplitude fluctuations of the received navigation signal, that is scintillation and fading. I will consider this problem on next slide. This slide illustrates double hump effect of the ordinary and extraordinary wave in the Kokaima plot. I mentioned above that we discovered new effect recently, and we have named the double hump effect as far as the spatial power spectrum has a double peaked shape. Collision between plasma particle leads to separating of the maximum, and depth of a gap increases due to collision between plasma particles for the ordinary waves. And this slide, right figure illustrates formation of a double hump effect caused by different inclination angle taking into account the diffraction effect. This slide illustrates the spatial power spectrum of the extraordinary waves and the ordinary waves for different parameters characterizing anisotropy of electron density irregularities. Now we consider the temporal spectrum in the conductive equatorial ionosphere. Nobody considered statistical characteristics of scattered radio waves in the equatorial ionosphere, not taking into account the conductivity of the ionosphere. This is first result of our investigation, and the upper panel illustrates the three-dimensional picture of the temporal spectrum versus non-dimensional distance parameter and frequency parameter. Right figure on the upper panel illustrates the broadening of the temporal spectrum for different anisotropy parameters characterizing the elongated plasmonic structures and angle of inclination. Increasing the anisotropy factor, the broadening decreases and maximum shift to the left. Left panel illustrates new effect. This is a double hump effect of the precursors arises in the temporal spectrum near the plasma boundary. So this effect is observed only for ordinary wave in the equatorial ionosphere. This double hump effect for the precursors not observed for the extraordinary waves and not observed in the polar ionosphere for both ordinary and extraordinary waves. Numerical calculations show that increasing distance traveling by wave in the Kokoima plasma and for different angle of inclination of elongated plasmonic structure with respect to the geomagnetic lines of forces and different anisotropy factors, the double hump effect disappears. Now, this is a video which illustrates the double hump effect for small-scale irregularities of electron density fluctuations in the Kokoima plasma. This is original illustration of the double hump effect for small-scale irregularities. This slide illustrates video of the double hump effect for large-scale irregularities. The formation of a gap for small-scale and large-scale irregularities are substantially differs. The broadening of this double hump effect for the large-scale irregularities substantially exceeds the broadening of the double hump effect for small-scale irregularities. This slide illustrates the dependence of the scintillation index on the variance of the root mean square deviation of electron density fluctuation in different phase spectral index P, it experimentally observing parameter. At the satellite radio navigation system, 50 degree. The error of the phase of radio signal radiating by satellite radio navigation system consists on the statistical characteristics, following statistical characteristics: the variance of the phase fluctuation of the signal, the variance of the thermal noise, and the variance of the generated noise. This slide illustrates the influence of the scintillation caused by a root mean square deviation of electron density fluctuations. This slide illustrates the dependence of the scintillation level versus root mean square deviation of electron density at the vertical sounding of radio waves. In this case, the behavior of this curve are quite different than in previous case. Scintillation index cause, in this case, characterizing low intensity scintillation. This condition, average intensity, and this one, high intensity scintillation. Experimental observations show that in equatorial region, scintillation is equal 0.3, sometimes reach to 0.8. At high altitudes, for example, in the polar ionosphere, scintillation index is quite small. It really exceeds 0.2. Now, I consider the scintillation effect in the ionosphere. This is a usual formula connecting the scintillation level with the correlation function of the phase fluctuation describes the diffraction pattern on the ground. Sinusoidal term is responsible for the oscillation. We have discovered 3 zones in the scintillation spectrum. This left zone is associated with the significant filtering non-full developed diffraction pattern. Right area is associated with the fully developed diffraction pattern, and shaded area is a transient region between these two areas. And
Excuse me,
this
sir.
minimum in fully developed diffraction pattern satisfy the relationship 1, 2, 3, 4. Small scintillation level is associated with reconduction, and this condition describes the large scintillation level. And
Excuse me, sir.
this slide.
I'm
Yes,
sorry
yes,
to
yes.
disturb you, but I just wanted to remind you of the time. We are running out of it.
Yes, only 1 minute or 1 minute.
Yes, sir. All right, all right.
Thank
Sorry.
you, thank you. And this slide illustrates the possibility of generation of new excitation waves arising in the ionosphere for different anisotropic parameters. And finally, this slide illustrates the generation of new waves propagating in the ionosphere and in space. I would like to pay attention on these figures. The powerful splashes arises in the energetic spectrum, transforming their energy into turbulence, increasing its energy. Turbulence has an influence on the meteorological parameter in the lower atmospheric layer, leading to the climate change. So the scintillation can lead to the climate change in any place of the terrestrial ionosphere. This is the conclusion of my presentation, and thank you for your attention.
Yes, any questions from the audience or participants? I think we can proceed to the next presentation. I have no question.
Yes, sir. Okay. We'll be proceeding with our last presentation. I'd like to invite presenter Raghav Pora to present their paper titled Vitiligo Detection Using Machine Learning Algorithms. Please go ahead.
So the title of my presentation is Vitiligo Detection Using Machine Learning Algorithms. So it is presented by me, Raghav Bhaura, and authors are me, Rahul Nichavan, Neha Mehendiratta, Madhushi Verma, and Sayam Kumar. So vitiligo is the most widely recognized skin illness on the planet. According to WHO, the number of individuals experiencing vitiligo is increasing by time. In this paper, we propose a novel deep learning-based architecture for vitiligo detection. It is capable of evaluating and classifying vitiligo images with high accuracy and identifying whether the image contains the skin with vitiligo or not. We utilized pre-trained deep learning models here, namely Inception v3, VGG19, and VGG16. Our proposed approach has outperformed the state-of-the-art algorithms with an accuracy of 96.5%. So white spots or patches caused by selective restriction are the clinical characteristic of vitiligo, a dominant multifactorial pigmentary condition of the skin. Vitiligo's pathogenesis is not yet fully understood, but a variety of factors, including autoimmune, may play a role in its onset. Nowadays, deep neural network models like CNN have been extensively tuned for vitiligo classification. Yet CNN is slightly different from standard neural networks in certain aspects. The depth, height, and width of CNN layers are organized in 3 dimensions, and the neurons in one layer do not connect to those in the layer above it. Nonetheless, The final result is reduced to a single probability score vector that is well ordered towards the depth in a very restricted area. So the related work uh, around this topic is the study proposed by Mohammad Sabiri and others stated that the strategy for various focused image recovery procedures to identify the human body skin. For the recognition of image of skin, they introduced a new methodology. They compared the outcomes from a few of the previous works, indicating that low computation power is required by this strategy. Amarthunga and others performed different approaches for early detection of various skin diseases like naive Bayes, AdaBoost, MLP, and J48. In the wake of executing this large number of grouping strategies, they obtained various exactness, yet all are over 84%. The study proposed by YP Govrama, Pavitra, and others primarily aimed at the skin surface that is used for detecting healthy skin. And from the point on, the multi-class classification technique yields excellent results from grouping. The study of Sanjay Jaiswal and others distinguished diseases of the skin, utilizing various elements of tumors of the skin, for example, deviation of melanoma skin disease, the boundary of malignant growth, and multiple components. So we to utilize the data set. The data was acquired by taking consideration of clarity and visibility in order to obtain best results without any errors. The dataset contains 101 images without vitiligo and 101 images with the vitiligo. This information and dataset were obtained from Kaggle and Google. So, employed classifiers in this research is logistic regression. So, logistic regression is fundamentally equivalent to linear regression, except for how they are used. LR is used to deal with backsliding issues, while key backsliding is used to deal with portrayal problems, which is perhaps the most commonly used AML estimations for two-fold request problems. AdaBoost. The classifier AdaBoost, whose calculation represents versatile exponential, is an exponential procedure utilized as a manufactured technique in AML. It is also known as the adaptive boost because the heaps are brought together for all events with a high burden on ineffective portrayed issues. Naive Bayes. The naive Bayes classifier, whose pursuit is a coordinated numerical activity, relies upon the Bayesian hypothesis and is utilized for handling cluster issues. The classifier is among the simplest and most effective ones in terms of computation that assists with building quick AI models for making fast computation. Another is support vector machine. This classifier is likewise a type of AI model that is applied for regression and classification issues. Nonetheless, this is generally used to categorize things. The SVM methods construct the techniques for allocating to binary linear classifiers with probability. Another classifier used is k-nearest neighbor. The k-nearest neighbor classifier is among the least complex artificial intelligence estimations, which depends on the previously modified learning techniques. Its calculation is non-parametric, implying it makes no prediction in light of the information within reach. It's otherwise called a lazy learning algorithm, as it does not immediately gain through the readiness of the dataset. Another is AdaBoost. The random forest classifier is an AI model used to tackle classification and regression issues. Ensemble learning a strategy that is utilized to solve complex problems. So the outcomes of this research are by using VGG19 model. This is the table for comparison of various handcraft ML algorithms by VGG19 model. From the data in the table, we can see that 94%, 94.6% is the maximum accuracy we are getting from VGG19 model and logistic regression classifier. This is the ROC curve for the VGG19 model and various classifiers. Inception V3 model. In this table, it is the comparison of various ML algorithms by Inception V3 model. From the data in the table, we can see that 96.5% is the maximum accuracy we get utilizing the Inception V3 model and logistic regression classifier. This figure represents the ROC curve analyzing the action of various classifiers for the Inception V3 model. Another is VGG16 model. This table represents the comparison of various ML algorithms by VGG16 model. From the data in the table, we can see that 92.1% is the maximum accuracy we get utilizing the VGG16 model and logistic regression classifier. This is the ROC curve that represents the various classifiers actions for the VGG16 model. So concluding, this research helped to minimize the time to find whether one have vitiligo or not using AI techniques, and hence helpful for specialists and doctors in identifying vitiligo in timely and efficient way. We have utilized the three pre-trained CNN architectures for fine feature extraction, that is Inception V3, VGG19, and VGG16. The outcomes specify that utilizing the Inception V3 model for extraction of features and logistic regression for the classification produce an accuracy of 96.5%. Several more factors can be taken into consideration as future possibilities for further study of the vitiligo disease based on the data we are able to get. The study can be strengthened by expanding the dataset image count. Thank you for listening.
Thank you, presenter. We go ahead with the questions. Any questions, anyone?
Yeah, I have a question. In fact, there's a good presentation. In fact, you use too many machine learning algorithms. Did you use any tool like Wika tool for experimenting, or did you write the code to experiment all this?
We write the code for experiment all this.
Oh, did you write the code for all those algorithms? There's too much of load. Did you hear about the Wika tool? All what you have mentioned, all the algorithms, you can find it in a single tool called Wika tool. So you can try that.
Yes, sir. I will try that too. I have heard first time about this tool.
Okay.
Thank
Yeah,
you
that's a wonderful tool to use, machine learning algorithms. Right, thank you. I'm done from my side.
Okay, sir.
No more question from my side. No question from my side.
Okay, sir. That actually concludes our meeting. I sincerely thank our authors for their excellent presentation, contribution in this session, and all our participants for being a part of this international conference. I hope this session was informative enough. We, on behalf of the whole team, thank you for the support during this 7th version and all the previous 6 versions of the conference. We will be happy to have you in the 8th version in 2024. All the presenters would be getting their digital certificates through email within 2 working days. Furthermore, the papers have been already forwarded to the Springer. The publication will be live within 6 months. Kindly cooperate with the team of WS4 2023. I also thank our session chair, Professor Nilesh Modi, for chairing this session. A token of appreciation to the chair on behalf of Team World S4 2023 and Global Knowledge Research Foundation partners. Thank you very much, sir, for your presence.
Goodbye.
I'd also like to thank our session chair, Professor James Stephen Maker, for your valuable presence.
Thank you so much.
Dear all, I kindly request you all to turn on the camera for a quick snapshot of the virtual conference. Please turn on your cameras. Thank you. That's it for today, everyone. Stay safe and take care. Thank you, everyone.
Thank you.